This video will talk a little bit about hypothesis testing and then how to use Minitab to solve some of these problems. So this one here is talking about 80 eighth grade students um, with a mean score of 277, standard deviation 38, and the school's thinking that their eighth graders scored more than 270, so that'd be greater than 2070. And this is the claim. And the claim is always the alternative. Okay. So it might be easier to figure that one out first. And then we want to figure out what the starting point is. So the starting point would be definitely with an equal to in there, because this one's greater, this one will be less than. Equal to 270. So that'd be the first one. If the claim was less than, then H naught would be greater than, equal to. If the claim was different, then H naught would just be equal to. So those are the only three scenarios that you can have. So it says find the standardized test statistic Z and its corresponding area. So the Z score, remember, is x bar minus mu over sigma over square root of n. And we can use this because our sample size is greater than 30. We have 80. So x bar is going to be the 277, the number we have in the problem there, minus the 270, which is our assumption to start with. And then we have the standard deviation of 38 over the square root of 80. So if we plug this in, 277 minus 270 divided by 38 divided by the square root of 80, and I am getting a z-score of 1.65. I'm rounding it to 2 decimal places. Okay. And then we have to find the area. Now what you can do is go over to Minitab, and we're testing against 277. So the mean is 277, the sample mean. We're going to put that there. And you can go to Calc, Probability Distribution, and then Normal. And then we're going to do a Cumulative Probability Distribution. And we're going to fill in our mean, which is 270. And then our standard deviation, which would be your sigma, which is 38 divided by square root of n, so square root of 80, and you would get a standard deviation of 4.249. So I'm going to do 4 point, and I'm rounding it to 3 decimal places. And then if we hit OK, we're getting our probability here. And let's go ahead and try this. So 0.950, and we'll check our answer. And there we have it. So we can go ahead and use calc probability distribution, normal distribution, and then cumulative to find the area to the left. But we're actually looking for the p-value, which is going to be the area to the right. So you're going to take 1 minus the 0.95, and you're going to get a p-value of 0.05. And we'll check our answer. And then we need to decide whether to reject or fail to reject the null hypothesis. So the next part is we're going to decide whether or not to reject or fail to reject the null hypothesis. So what we're looking for here is are we far out in this tail here? Okay, so are we less than this 2%? So our alpha equals 0.02. So we're looking for our p-value to be less than 0.02. And if we look at our p-value, it's actually greater than, so we're going to fail to reject H naught. So there's not enough evidence. So at the 2% significance level, there is not enough evidence to support the administrator's claim that the mean score for the 8th graders exam is more than 270. Okay, so that was number 12. So let's look at another problem. This is looking at a company that makes cola drinks, and it states that the mean caffeine content is 35 milligrams. So you want to test this claim, and it doesn't say we think it's higher or lower. So when it's just saying that it's possibly different, your null hypothesis is going to be mu equals 35, and then to result different, you're going to use not equal to 35. So if we go back to this curve I had here, this is a two-tailed test. So if it's a lot higher or a lot lower, we're going to go ahead and reject the null hypothesis. So next thing we have to do is find the critical values, and what it's looking for is a z-score. So there's different ways to look at these problems. Sometimes one way to look at it is to look at your z-scores and see if you come up with a z-score that's a lot higher in this case or a lot lower. The last one we used was p-values, and we're finding the same thing, just using a different method. So the critical value is telling us it's a two-tailed test, and alpha equals 0.07. So what you want to do is take the 0.07 and divide it by 2. So we're going to have 0.035 and 0.035 in the tails. So we're looking for this here, but when we're looking for a critical value, the way the programs look this up, you need the entire area to the left to find this value, or we could just find this one starting here and just use a 0.035, and then we would get a negative z-score. Because it's symmetric, we're going to get the same z-score, but one will be positive and one will be negative. So if we want to, we can just use this 0.035, and what we want to do is, so again, we're going to use Minitab, and what we're going to do is we're going to use a slightly different function. So what we need to do is put in the value to the left of the z-score that we're looking for. So we're going to put in 0.035, and then we're going to go back to calc, probability distribution, and then go to normal, and then this time we're going to choose inverse cumulative probability. And we're using z-scores, so we're going to use a mean of 0 and a standard deviation of 1. So our standard normal curve. And then we're going to use, again, our C1 where we put this 0.035, and we hit OK, and it's going to give us our z-score that corresponds to this guy here. So this is negative 1.81. Because it's symmetric, this is 1.81. If you wanted to find it, you would need the area to the left here. So if we took 1 minus 0.035, we find that this area to the left from here to here is 0.965. So if we went back to Minitab and we put in 0.965, and we did this again, calc, probability distribution, normal, and then hit OK, you'd see we got now the positive version of this. So we have our two z-scores. So the critical value is 1.81. So we want to identify the rejection region, and the rejection region is always going to be in the tails. So we're going to reject if it's in either one of these tails. So we're going to choose A because it's a two-tailed test. And then we need to find our z-score. So what we're going to do is take this 37. This is the sample we found. So this is our z-score. And we're going to subtract off what we're testing against, which is the 35. And then we need to use our standard deviation, which is 7.4. Which is 7.4 divided by the sample size, which actually is square root of the sample size. So we're going to take the 33.7 minus 35, and then we're going to divide by 7.4 divided by the square root of 30. And then we're going to get negative 0.96. So we want to round to 2 decimal places. And we're going to go ahead and check our answer. Okay, so now we have our z-score. And what we're looking for is a z-score that is outside, in this rejection area here. So z-score we found is negative 0.96, which is, so if the mean is here, and this would be probably about 1 standard deviation is right here, and then 2 would be here, and then we're looking outside here, but we're not outside there, we're about here, which is negative 0.196. So we can look at these next choices. Z is not in the rejection region. We failed to reject the null hypothesis. So it's not in the rejection region, it's in here. So we failed to reject. And so now we can summarize the answer in words. So at the 7% significance level, there's not enough evidence to reject the company's claim that the mean caffeine content per 12-ounce bottle of cola is equal to 35 milligrams.